Hi guys, I came across this meme. I've seen images like this before. I always thought they were from a video game or something. This image got me to do some investigating about the subject, and I found a few more similar pictures. So before I get to those, I'm going to read this meme. It says, before sunrise or after sunset, the sun is below the horizon, but the sun can reach the clouds above. If there is a mountain between them, it can cast a shadow on the clouds. This is impossible to occur on a flat earth and can only happen if the earth is spherical. Now, I would admit that these images look fairly compelling as proof that the sun is actually going down. So I wanted to do some more investigating about this. And the first image here is from Mount Hood, Oregon, as you can see. Unfortunately, a lot of these images don't actually list the place of where they were taken. Part of my personal incredulity about this being video games or whatever is I'm from the mountains. I was born in the mountains. I live at 7,600 feet elevation, and so I've never seen this personally, which I found really odd, because I'm constantly looking up at the sky, constantly watching the sun and the moon and stars. It just didn't make a whole lot of sense to me that I've never actually personally seen this, having lived in the mountains many years. Next image here we have Mount Rainier in Washington. Having lived in Oregon for several years, I kind of know the landscape, so I know that Mount Rainier is fairly close to Mount Hood. It really got me wondering if this was some kind of local phenomenon or if there's other places that this occurs. As I already said, it's kind of hard to find images that list the location, but I found this one from the Grand Teton Mountains in Wyoming. This one actually listed the location where the picture was taken from, so I had a visual reference that I could go to Google Maps and try to wrap my head around this. It was kind of troubling because in order for this to occur, the sun would have to be really, really low. Unless, of course, there's a reflection causing it. So that was my next line of reasoning. I wanted to know if it was possible that there's a body of water on the other side of the mountains causing the reflection upward. Going back and looking at Mount Rainier, and then looking at it in Google Earth, I was noticing that directly to the west is the Pacific Ocean. And there's no mountain ranges, barely even any hills in between Mount Rainier and the ocean. Distance was approximately 112 miles according to Google Earth. Going back to Mount Hood and looking at it in Google Earth, it's almost the same exact conditions as Mount Rainier. By that I mean the Pacific Ocean is directly to the west in the direction of the setting sun at certain times of the year. So I used the Google ruler tool to see exactly where the ocean was and how far. I wanted to stay as close to the lines of latitude as I could. And again, there was not very many hills or mountains in between Mount Hood and the ocean. The approximate distance was 110 miles. I had actually found the images of Mount Rainier and Mount Hood before I found the image of Grand Tetons. And I was prematurely making hypotheses about this occurring only near large bodies of water. So when I found this image from the Grand Teton mountain range, I began to question my hypothesis on whether or not this was a valid assumption, because I was not very familiar with the geography of Wyoming, to be honest. This image was actually pretty nice because it told me where it was taken from the Grand Targhee Resort, and it was a sunrise, so I knew that depending on the time of year, the sun could be rising from the northeast, directly east, or southeast. Just going back to the image here, you can see that there's still snow on the mountains. I went back to Google Earth and found this image on the street view. I'm pretty confident this is the same mountain range, taken in the summertime rather than the wintertime. As you can see, I've overlaid the image on top of the other image to show that this is indeed, in fact, the same three mountains. Direction was facing southeast. Going back to Google Earth, I went to the Grand Targhee Resort and wanted to see if there was any water directly on the other side. So as before, I used the ruler tool. And what do you know, there's a big lake on the other side. Several lakes, actually. Also, when the photo was taken, it was wintertime, so this whole area over here would be covered with snow, which could reflect sunlight. My findings were inconclusive. I really wanted to do this experiment on my own to figure out if this is actually happening. Living in the mountains gives me a lot of opportunities to actually test this theory. So that's exactly what I did. I had to wait for the weather to be right, where there was no clouds in the sky, to obstruct the light that was coming from the sun. As you can see here, I indicated the direction that I was facing, and if you look, you can actually see the mountain in the background that I'm going to be filming. There's no clouds in the sky, so there's no obstruction. If the sun were truly going down as opposed to away, you should see these shadows climb up to the top of the mountains. Here I show the direction that I was facing. At this point, I'm going to speed the video up a little bit. Also notice the crisp shadow line appearing on the mountain. As the time goes on, this crisp line will fade out. At this point, you can see the light begin to fade. Notice it doesn't climb to the top of the mountain. It stays there and then fades out evenly. The crisp shadow line begins to fade. Also, you'll notice that this mountain in the background, the light fades evenly as well. Just going back here for a minute, I'd like to point out that this tip of this mountain is actually causing this shadow. And if you watch closely, this shadow fades out at the same time as the shadow on the mountain in the foreground. Notice the shadow doesn't climb up the mountain as you would expect it to do if the sun was actually going down as opposed to away. Also, I'd like you to take note of this cemetery that's in the image here. Going back to Google Earth again, I'm looking at my observation point and my target. Take note of all the crisscross lines on this mountain. Also notice there's no large bodies of water nearby. And here's the cemetery that I pointed out earlier. So if we're looking at the scientific method here, number one is question. Ask yourself what I want to learn more about. 2, hypothesize. Research to help you make an educated guess or hypothesis, and then answer your question. Number 3, experiment. Test your hypothesis by making a plan and conducting an experiment. Observe and record. Make careful observations and write down what happens. Number 5, analyze. Use your information to draw conclusions about your experiment. Was your hypothesis correct? Number 6, share results. Explain your results by presenting your experiment, observations, and conclusions. Question. Wanted to learn more about shadows cast from mountains onto clouds. Hypothesize. Made hypothesis that shadows are only cast upwards when there are bodies of water or snow adjacent to the mountains casting the shadows. Experiment. Made an experiment to test the hypothesis by filming mountains during sunset from more than one location, obtaining the same results. Observe and record. Made over 5 observations with the same results consistently and recorded my findings. Analyze. According to my findings, mountains casting upward shadows can only be caused by reflections off water or some other reflective surface adjacent to the mountains causing the shadow. When oceans are on the horizon and little elevated topography exists between the mountains and ocean, distances of 111 miles are not uncommon. The sun moves away from the observer, causing the shadows to fade out and not rise to the top of other mountains, let alone clouds above. So now there's only one thing to do: fix the meme. Some additional data provided 3 instances of shadows cast onto clouds, and that there's bodies of water adjacent to all 3, strengthening my claim that this is caused by reflections off water, not because the sun goes down. Also giving validity to my claim that the sun moves away.